I'm going to present the encapsulation and inheritance of our program. The overview of our program is to demonstrate encapsulation and inheritance by modeling three classes: vehicle, car, and truck. The vehicle class is the base class with common attributes like brand, model, and year, encapsulated with private access modifiers and accessed by a getter and setter methods. The car and truck classes inherit from vehicle, adding unique attributes like numbers and load capacity. Both classes override the displaying info method to include specific details and provide additional method for car and load goods. To showcase their unique behaviors, this structure highlights how OOP principle can create reusable and extendable code. For our class, the vehicle class is the base class that holds common attributes and method shared by all vehicle types like car, truck, and motorcycle. It demonstrates encapsulation by keeping its fields private and providing getter and setter methods for controlled access. For our another class, the car class is a child class that inherits from the vehicle base and adds additional properties and behavior to specific cars. This demonstrates inheritance because car shares common fields methods from vehicle while also introducing new fields and behaviors. For our another class, the truck class is another child class that inherits from the vehicle base class. It introduces the load capacity attribute, which is unique to trucks and demonstrates the same principle as the car class. And for our method, we use the getter and setter methods. These methods allow controlled access to the private field, and it allows us to update it. This ensures encapsulation by preventing direct access to the fields. And for constructor, the constructor vehicles initialize the brand model and year attributes when a new vehicle object is created. The constructor car calls the constructor of the superclass using super passing brand, model, and year to initialize and inherited fields. It also initializes the numbers specific to the cars. To demonstrate of how objects are created and how methods are invoked. When vehicle display info is called, it displays general vehicle details. When car display info is called, it displays details specific to cars including the number of doors. When truck 1 display info is called, it displays details specific trucks including the load capacity. The honk method is invoked on car 1, which outputs are car specific behavior. The load goods method is invoked on truck 1, which output a truck specific behavior. For conclusion and summary, in conclusion, this program provides a clear demonstration of fundamentals of object-oriented programming, particularly encapsulation and inheritance. Objects are created using constructor with the new keyword initializing attributes of the class. Encapsulation is showcased by marking fields like brand, model, and year as private in the vehicle class, ensuring controlled access through public getter and setter methods. This ensures data security and integrity. Inheritance allows the car and truck classes to inherit common properties and methods from the vehicle base class, promoting code reuse and maintainability. Method, method overriding is also demonstrated, where the displaying info method is customized in car and truck to provide specific details for each subclass. Methods like honk and load goods are invoked on objects to showcase class-specific behavior. Overall, this program highlights how OOP principles enable scalable, organized, and maintainable code, making it easy to model real-world entities effectively.
In our program, we have two fundamental object-oriented programming concepts. The first one is encapsulation. What's the meaning of encapsulation? Encapsulation refers to the bundling of data, fields and attributes and methods, functions and behavior into a single unit or class. It also restricts access to certain data to prevent it from being modified directly, which is done by marking fields as private and providing public getter and setter methods control access. The second one is inheritance. Inheritance allows a new class, subclass, and child to acquire the properties and behavior, fields and methods of an existing class, superclass, and parent. This enables code reuse and establish a natural hierarchical relationship. In our program, we have four class, which is vehicle class, which is base class, car class, which is derived class, and truck class, which is also derived class, and last one is main class. In our program, we use constructors. The constructor we use is vehicle, car, and truck, which is name of our class. And the methods we use are getter and setter methods. Getter and setter for num doors, overridden display, getter and setter load capacity, and overridden display and load goods.